Hi guys, this is lesson 3 in unit 11. We're going to talk about histograms. So this is what we learned so far about organizing data. We talked about frequency tables, and frequency tables are tables that include the data points in a data set and the frequency of each data point in the set. And we talked about organizing or graphing the data using dot plot. Today we're going to talk about organizing data using histograms. And histograms are a graphical representation of an interval frequency table where the intervals from the table are placed on the x-axis and the frequencies for each interval are represented on the y-axis. Let's take a look at our first example, because unless we do an example, we're not going to be able to understand what an interval frequency table means. So we have this example where we have 20 students were selected to measure the length of the east hallway of their school. 2 marks were made on the hallway floor, one at the front of the hallway and one at the end of the hallway. Each student was given a meter stick. Students were asked to use their meter sticks to determine the length between the marks to the nearest tenth of a meter. And these are the results recorded. So we have 20 data, and since we have a lot of data, we have 20 data points, we're going to have to organize these data in what we call an interval frequency table. An interval frequency table is just a frequency table, but instead of the data points that we put at the first column, we put intervals, which include intervals that include specific data points. And then the second column, if you want, that's optional, is the tallies, and the last one is for the frequency. So let's try and find out how we're going to do this interval frequency table. My data goes from 8.1 to 8.9, and I need to make 5 intervals to accommodate all these data. So I'm just gonna try and do my best to come up with the best intervals that can represent all these data. So let's start by maybe starting with 8 to 8.1. So this is my first interval, all data points from 8 to 8.1. And then my second interval is from 8.2, because 8.2 comes after 8.1, to 8.3. These intervals are supposed to be equal in size. That means I have 2 data points here that I'm including. This interval has to have the same thing, 2 data points. And then my next interval is going to be from 8.4, because 8.4 is what comes after 8.3, to 8.5. Next interval is from 8.6 to 8.7. And then my last interval is from 8.8 to 8.9. So let's look at these data. We have 1, 2 data in the first interval. And then we have 8.3 that goes into the second interval. Then we have 1, 2, 3, 4, 5, 6, 7 data points that goes into the third interval. 4, 5, 6, 7. Then 8.6, 1, 2, 3, 4, 5, 6 goes into the next one. 2, 3, 4, 5, 6. And then 8.8, we have 1, 2, 3, 4. We have 4 data points that goes into the last interval. So now I have 2, 1, 7, 6, and 4. And this is how you construct an interval frequency table. You look at the highest score or data, the lowest one, and try to come up with 4 or 5 intervals that accommodate all these data points. Now we're ready to construct a histogram. So for the histogram, I need an x-axis and a y-axis. My x-axis is going to represent the intervals, and in this case we have length intervals. And the y-axis is going to represent the frequency. Now, if we look at the interval frequency table, we'll see that I'm not using a number line to represent these intervals. I need to make bins on the number line to represent each interval as a specific point. And if you look at the smallest value in these intervals, it's not a 0. And since I'm not going to put these intervals on a number line, and I'm not going to start with 0, I'm going to just make this symbol at the beginning of the x-axis to show that I'm not going to start with 0. And I'm going to put my intervals, as I said, into bins. And this is how I represent these bins on the number lines. Each bin is going to represent a specific interval. So we have 1, 2, let's put it in the red color, 1, 2, 3, 4, 5 bins, and each bin for each interval. So our first bin is for the interval from 8 to 8.1. And then our second bin is from 8.2 to 8.3. Next is 8.4 to 8.5. Next one is from 8.6 to 8.7. And the last is from 8.8 to 8.9. So again, if you look at the x-axis, we don't have a number line. We have bins. Our first bin doesn't start at 0 because our the first number that the first bin starts with is 8, and then we have this break to indicate that we do not start with 0, and we're just going to ignore the numbers between 0 and 8. Now for the frequency, the highest frequency that I have here is 7. So I'm going to go from 0 to 1. And I don't need a break here because I'm starting with 0, 2, 3, 4, 5, 6, and 7. So again, the length intervals are on the x-axis and the frequencies are on the y-axis. So now our first interval has 2 data points. So my first bin should go up to 2. So this is my first bin, and I need to shade it. And it indicates it goes up to 2. That means we have 2 data points in this bin. Now, or in this interval. For the second interval, we have 1. So my second interval has this height, and it has just 1 point. Third bin has 7. So my interval is going to go up to 7. And it has 7 data points. Next one has 6. So this one is going to go up to 6. I'm going to shade right here. And then the last one has 4. So it's going to go up to 4. And I'm going to shade right here. So I have 2 in the first bin, 1 in the second bin. I have 7 in the third bin, 6 in the fourth bin, and 4 data points in the last bin. And this is how you construct a histogram. These bars should touch each other because each bar represent a bin or an interval, a specific number of data point in each interval. Now, if we take a look at this histogram, we'll find out, because we're trying to describe the shape of this histogram, we'll find out that this histogram have this shape. And this shape tells us that the mean and the median is somewhere here at the top of the mountain, and the left side is different than the right side, which means that this histogram or this data set is skewed, or it has a skewed distribution. And it has a skewed distribution to the left because the tail of the distribution, which is right here, is at the left side. So this distribution is skewed left.